The standard Compose SDK comes with a lot of pre-built UI elements, and most of the time they are more than enough to build the UIs we need to build day by day. However though, sometimes we need some specific behavior that we couldn't easily achieve with the built-in components. And in those situations, our best option would be to build custom layouts. In this video you'll learn how to build your own custom layouts in Compose, what are all the different aspects you need to take in consideration when doing so, and you will get much better understanding how the measurements work in Compose. Let's do this. In this preview I have two composables and both of them look like a row. The first one, however, is a custom composable that I built on my own. The second one is the standard row that comes in Compose SDK. The behavior I want to achieve is I want each element to be able to grow independently as long as the whole thing fits in the row. When it no longer fits, I want the row to split in equal sizes, depending on how many composables are inside, and then give each of them equal width. As I will demonstrate in a bit, this is not something we can easily achieve with a row. And as we are going to learn in this video, achieving this with a custom layout will be very easy. First, let me show you how the custom layout works so you get better idea what I'm trying to achieve. As you can see here, I have this custom layout composable and it expands across all the available width. It is being rendered inside a column that has width of 300. Now if I reduce here the size to, let's say, 250, the whole content still fits, so there is no much changes. But if I reduce it to 200, the content no longer fits, and therefore the custom layout will just split equally based on how many children it has. In this case we have 3 children, so it's gonna split into 3 equal pieces and it will dedicate equal width to each and every children. Now if I try to put, let's say, the second one bigger, it still no longer fits, so it just remains as it is. And if I make it single line as well, it will just wrap the height, and that's the behavior that I'm trying to achieve. And if I reduce a little bit so that it fits, it will just insert it inside the whole thing. Now let me bring the parent back to 300 so that the whole content fits inside. And now if I reduce a little bit of the third children, as we can see, each children takes as much space as it needs, and then the rest of the space is split equally in each and every child. Lastly, let me increase the size of the first one a bit. Now let's see what are our options with the standard row. In this row I also have the same 3 children, and this row also expands across the whole available width. The first option that I have with the row is horizontal arrangement, and here I'm gonna apply space evenly, and as we can see it doesn't help me much because there is this additional space that is around the children, and that's not what I want. To fix it, I can try to apply weight of equal value to each and every children, and now this is the behavior that I want when the content doesn't fit inside the row, just as we saw with a custom layout. But here we do have enough space and it is still not behaving the way I want. Even if I comment out the space evenly now, it wouldn't make much change because the weight is still 1 everywhere. And if I comment out the first 2, it would only increase the last one. So I don't have the possibility to dynamically increase or decrease each and every children. And that's the limitation that I have with a standard row. Now let's go ahead and see how this custom layout is implemented and how we can implement one on our own. So here is the custom layout composable that I've built for this video, and as always I'm gonna put a link below this video where you can access the code so you can see it on your own too. I would like to walk you through all the different aspects of building a custom layout so that you get better understanding and you can do that on your own. First things first, the content comes in as a composable lambda, and inside we are utilizing this layout composable that comes as part of the standard SDK. Then I'm just passing down a modifier and a content, and then things become way more interesting because I have this lambda that gives me back the measurables and the constraints. And before we proceed with the code, I would like to show you what these measurables and constraints mean, what we can do with them by doing a little bit of drawing. So here is our custom layout. And for the preview that we saw in the code, this custom layout is wrapped in a column that has width of 300 dps. Next, we can represent the content that we are passing in the custom layout like so. So we are having these 3 text composables that are having different width. Now, those individual composables that we are passing inside are the measurables. So we can measure them, and by measuring them, as we can see in the APIs, we are producing placeables. And then we can use these placeables later on to place them on specific positions. So that's the philosophy. We have measurables that are coming in, and by measuring them, we convert them into placeables, and then those placeables we can spread across as we want. The constraints on the flip side are telling us what's the max available width and height that we can utilize when measuring our measurables. So what is the constraint of the outer box? In this case, we have a column that has width of 300, as we can see, so this here, and that is our constraint. So we have measurables and we have constraints. And by using both of them, we can measure how much space we can have for each and every children based on some math or business logic that we may have. And in this case, the behavior that I want is if my children are smaller than the available space, then they're gonna spread evenly across all the available space and take equal portion of the space, and then they can grow independently as long as there is enough space by pushing the others on the side. And when there is not enough space, it would get back to evenly split. That's the behavior that I want. So let's see how I have implemented that. The first thing that I'm doing here, I'm seeing what's going to be the height that I will need. And to do so, from all the measurables, I'm going to take the one that has the maximum intrinsic height, considering the width. So this mean intrinsic height will calculate what's going to be the minimum height that I need to render the children properly, so they are not going to be cut off. To demonstrate that here, if this is my container, and then inside I have one children like this, then one children like this, then another like this, this will be the height that will be calculated. So the height of the biggest children will be taken in consideration. So that's the height that will be calculated here. Then what I do is I create a list of widths by mapping my measurables, and for each item I'm going to calculate what's going to be the max intrinsic width considering the maximum height of the constraints. And this operation does similar things, so it will just calculate what's going to be the minimum width that I need to fit everything for that particular children. To demonstrate that, if my children are these following three, and then they're having different sizes, let's say this one is 50, this one is 100, this one is 150, then the total is going to be 300. And I'm going to have a list of these numbers, 50, 100, 150. Please excuse my handwriting. And that's what I'm going to have here in these widths. And then I'm calculating here the total width that I would need in order to place all these children by summing up all the widths. Next, I'm defining a list that I call items to place, and this list is of type placeable. Now, these are the placeables that I mentioned before, and we'll see just in a bit how to create these placeables out of the measurables that we saw so far. And now I have this condition. If the total width that I need to place all my children is greater than the available width, according to the constraints that are coming in, then I have to do a little bit of shrinking, right? So what I'm doing in this case is I would see how much width I can have per each children. So item width would be all the available width divided by number of children inside. In this case, this measurable size will tell me the number of children. Next, I'm creating item constraints variable, which is a copy of the constraints that are coming in by passing their minimum width and maximum width that is going to be equal to the item width that I've calculated before. And now that I have both of them, I can say that the items to place is going to be the measurables map. And then for each item, I'm going to say measure and then pass there the item constraints that are coming in. So for each item, I'm passing their constraints so that the max and the min width is gonna be the item width that we have calculated. And for the height, we don't have to do anything, so that it's gonna take the intrinsic height of the item itself. Now this measure is something that takes in constraints and returns back placeable. And this map will go through each and every measurable, and it will transform it into placeable by giving these constraints. On the flip side, if the total width is smaller than how much space do I have available, in that case, I'm going to calculate the remainder. Here in the picture, if for example, I have all this available space and then my children are taking just as much space, this is the remainder that I have. So I will calculate this remainder and I will divide it by how many children do I have, and then each children will have the space it needs plus the part of the remainder that is calculated. So back to the code, the remainder is the maximum width minus total width, and then I would divide that by measurables count again. And a little note, here I'm using count, here I'm using size to demonstrate that there is no difference. You can use anything that is in your convenience. And now that I have that reminder calculated, items to place are going to be the measurables. I'm mapping them indexed because I need the index and the measurable itself. And then the item width is gonna be the width of that index, which was here. That's why I first calculated the widths. And as we remember, I have that list of widths here. And then it will take the width of that index, let's say 50 in this case, and then it will add the reminder to that 50. And finally, it will say measurable.measure. And then for constraints, it's gonna say min width and max width, again, the width that I have calculated. For me, this is pretty easy and straightforward, and I really hope that I made it easy for you to understand it as well. But I will also suggest playing a little bit with all this so that you will get a little bit better grasp what goes where, what's what, and how the things are working. Now that I have the items to place, I can start placing them. And to do so, I need to call this layout function that is available in the layout composable. The layout takes in width and height, and as a width here, I'm passing the constraints.max width because I want to fill out all the available space anyway. In both cases, I want everything to be filled out. As a height, I am going to use the height that I've calculated as a first thing here. Now, to do a little bit of demonstration here, I can say plus 100 so that you can see on the preview how it is going to grow. And as we can see in the preview, it took more than what it needs to place the children. And that's something that I want to avoid. So I did this to demonstrate how the layout works, what is the width and the height. And obviously, if, for example, in the preview, the second item doesn't have max lines and overflow, and then I grow it enough that it doesn't fit, its height is going to be the biggest among all three, and then the parent itself is also going to increase the height. So the height that we have calculated here is going to be the height of that middle item. Finally, I can start placing the items, and because I want to place them horizontally, I'm going to maintain at which position every next item is going to start. And that's why here I have defined this variable x that starts at 0. Then I'm looping through all the items that I want to place, and for each of them, I'm saying item place relative, where I'm passing x and 0, and I'll explain just in a bit what happens here. Then I'm going to increase x by that item width. So I'll just add the item width to x so that for the next loop, for the next item, x will increase and the next item will be placed where the first one finished. Back to the drawing, how this works. It starts with placing here. So this here is x, this here is y. And initially both x and y are 0. So it will start placing my first item, and once placed, x is gonna be increased to this. Then the second item, x is gonna be increased to this, and then the last item. And y is always 0, so it will always be placed here. Additional super important point about place relative is that it will take in consideration RLT, meaning that if you are having left to right or right to left, it will place the items as you would expect. Otherwise, there are other functions you can use, like place without this place relative. And that one, on the other hand, is not going to take the RLT in consideration. So you have to be very careful when placing the items. And I would definitely suggest spending a little bit of time with this, playing around and seeing how it works so that you get better understanding around the different APIs that are available. And finally, as an exercise for you, I would suggest trying to place these items so that they are going to be aligned in the middle. If one of the children is bigger, like this case, these two grow a little more, it's bigger, then one more try and the one on the right, they should be positioned in the middle so that this row will be sort of center aligned. So that's going to be something that you can try on your own and see how it goes. And in general, I hope that this explanation already throws a little bit of light how the custom layouts are working. And from now on, you can also build your own custom layouts when you have such need like this one. If you found this useful, please let me know in the comments below, and also let me know what would you want to see next. I'll see you in the next one.